Hello, this video is over area of circles. So before we do that, let's look at our number routine about a crop circle. A crop circle is shown to the left. What is the perimeter or the distance around this crop circle? Well, if you're finding the distance around or the perimeter, you're really finding the circumference. So let me get my calligraphy pen. This is a radius, so instead of using c equals pi d, I'm going to use c equals 2 pi r. So 2 is 2, pi is pi, the radius is 2 and 3/10. So, how do you want to answer this? Do you want to answer using pi as 3, pi as 3 and 1400ths, or do you want to leave it in terms of pi? If I leave it in terms of pi, two groups of 2 and 3/10 is 4 and 6/10 pi. So the circumference or the distance around is 4 and 6/10 times pi. However, if I want to use 3, so 4 and 6/10, if I want to use 8, 4 and 6/10 times 3 is 18 carried to 1. That's 13 and 8/10 mile. So the crop circle, the perimeter or the distance around this crop circle is 13 and 8/10 mile. So today we're going to be learning how to find the area of a circle. So what you're going to be doing is you're going to make an approximate count of square centimeters in each circle. Make it easier by counting a quarter of the circle and multiplying it by 4. If a partial square is more than half, count it as a whole. If it is less than half, ignore it. Write a number in each square as you count it so you do not get lost. Record your count in the approximate area of circle column below. So, for example, we have circle A. So, what is the approximate area of this? 1, 2, 3, 4, 5. This is more than half. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, less than half. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and these two will make 28. And so that's the area of a quarter circle. And there's 4 quarter circles, so 28 times 4 is 112. The length of the radius is 1, 2, 3, 4, 5, 6. Let's do circle B. In circle B, 1, 2, 3. The length of the radius is 3. And what's the approximate area of a quarter circle? 1, 2, 3, 4, 5, 6. And these two half and half make 7. And there's 7 quarters, so 7 per quarter circle, 7, 7, 7, 7. That's 28. And we're just going to do, for the sake of time, circle A and B. So how accurate do you think your count of the area of circle is? I don't really, I mean, it's okay, but I don't think it's really that great. What makes it difficult to get an accurate measure of the area of circle by counting squares? Because you have all these open squares right here. So it's not really a full square you're counting. So it's like you're putting like fractional of a square. So it's hard to count fractional of a square and curves of a square too. So now that we've done that part, now here's the next part. So our answers were was, I can't remember our answers. 6, 112, 6, 112. B was 3 and 28. Now determine and record the areas of each of the shaded radius squares. Record the approximate area of each of the circles. So here's A. I want you to find the area of this radius square. If this radius is 1, 2, 3, 4, 5, 6, And this radius is 1, 2, 3, 4, 5, 6. 6 times 6, the area of the square is 36. Let's look at B now. 1, 2, 3. 1, 2, 3. The area of this square is 9. So what is the quickest way to get the area of a radius square? What I did, instead of counting each individual shaded square, I just counted the one radius, the other radius, and I multiply it, length times width. So it's radius times radius, or r times r, or I did the square of the radius. Now, I would like you to find the ratio of the proximate area of circle to the area of the radius square. So 112 divided by radius square, area of radius square is 36. The ratio is 3.11. What about this one? The ratio of circle B is 28 over 9, and that is 3.11. So this area of the circle was 128, and this area of the circle was 28. So how do you, if you compare the area of the circle to the area of the square, it has a ratio of 3.11. Isn't that almost close to pi? I mean, we did estimate very well, and didn't estimate perfectly, but it is around pi. So how does the area of the circle compare to the area of the square with sides the length of a thing? It's a little more than 3. So I'm going to show you a simulation that explains this even better. So you have a circle that's 4 square radius. How many radius squares can be covered with the area of this circle? Well, let's see. 1 full square, 2 full square, 3 full square, and a little more. And if you actually count, that's 14. So 3 full squares and 0.14. And that gives us our formula as to why area of a circle is pi times radius square. So area equals pi radius square, which is pi times radius times radius. If you look at the simulation, they had a full square, radius times radius, and how many of those squares in this, how many squares? One, 2, 3, and 14. Stop right here. So it's 3 and 14. So 3 and 1400 are pi times radius is the area formula of a circle. So we're going to practice this. So, for example, here is a circle. The diameter of this circle is 20 centimeters. What would be the radius of this circle? Well, the radius is half of the diameter, so it would be 10 centimeters. To find the area, the inner part, the square centimeters of this circle, you have to use the formula pi times radius square. So pi times radius times radius. What is the radius of this circle? It is 10. So if you multiply 10 times 10, that is 100. Then you multiply it by 3 and 1400. 314 times 1 is 314. Have 2 0. It has 2 digits behind the decimal point. So the area of this circle is 314 square centimeters. Let's practice another example. This is a circle. What is the area of a circle whose radius measures 5 centimeters? So let's write the formula. The formula is area equals pi radius squared. Substitute the radius. Area equals pi. Substitute the radius with 5 square. And what is 5 square, or radius times radius, or 5 times 5? 25. So it's area equals 25 pi. You always put the number coefficient in front of the variable. So I would like you to use pi as 3, pi as 3 and 1400, and leave answer in terms of pi. So if I leave my answer as pi, area equals 25 pi. All right, let's replace the pi with 3. I substitute the pi with 3. 25 groups of 3 is 75 centimeters. So the area is approximately 75 square centimeters. What about in this example? Replace the 25 with 3, replace pi with 3 and 1400. So if I multiply 3 and 1400 by 25, that's 20, carry the 2, that's 5 plus 2 is 7, 5 times 3 is 15, placeholder, 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6, it adds up to 15, carry the 1, 8, 2 digits behind a decimal point, so 78.50 square centimeters. So a good guess, a good approximate is 75 square centimeter. A better estimate is 78 and 50 square centimeter, but the perfect answer is 25 pi. Let's try a last example. What is the area of a circle whose diameter measures 12 yards? What is the formula for area of a circle? Area equals pi radius squared. Substitute the radius. The radius of this would be 6 yards, so 6 squared. What is radius times radius, or 6 squared? 36. So the area equals 36 pi. So 36 pi, 36 pi, 36 pi. Use pi as 3. So I'm going to substitute the pi with 3. 36 groups of 3 is 108 square yards. What if I would like to substitute pi with 3 and 1400ths? If I multiply 3 and 1400ths times 36, that's 6 times 4 is 24, carry the 2. 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. Placeholder, 3 times 4 is 12, carry the 1. 3 times 1 is 3 plus 1 is 4. 3 times 3 is 9. If you add this all up, it is 103 and 400 square yards. And if you leave, so we have 108 square yard, good estimate, using 3 as pi. We have 103 and 400 square yard using pi as 3 and 1400. And if you just leave it in pi, it's 36 pi. Let's make sure I did the math correctly in case I did not, which is possible. No, I added correctly. Oh, stop. I knew I made a mistake. I had a feeling I made a mistake here. Because if 3 and 1400 is more than 3, how can my answer be smaller than 108? So that's how I checked. I knew I did something wrong. So I use number sense to help me out here. Let's look here. 4 plus 0 is 4. 8 plus 2 is 10. Carry the 1. 8, 1, and 4 is 13. Carry the 1. 9, 1, and 1 is 11. So what a shame. This should have been a 11. So 113 and 400 square yard. So what we just did is we practiced on area of a circle. Again, the formula is area equals pi radius squared, or area equals pi times radius, because a square radius, there's a little more than 3 that fits in a circle. That's where the formula comes from. One reason, one way. All right.